Hey everyone, I'm Aaron and welcome to Mastermind. Welcome back to day 3 of this challenge series. We're going to be doing a walkthrough of Advent of Code, challenge number 3, puzzles number 3, part 1 and part 2. Remember, this series is not about getting to the most efficient or elegant solutions, but rather breaking it down and solving these and, using core fundamentals. I have heard these get pretty tough and that we're going to have to be smarter about how we solve them. That's okay. We'll do that. But for right now, again, because I'm hoping to keep this a little bit language agnostic, I don't want to dive into anything super fancy just yet until we need to. But let's see if we can get this one done today as simply as possible. So we are on day 3. Let's hop into day 3. So binary diagnostic. So that already gives us 2 bits of information. Binary, 2, 1s and 0s, on or off, yes and no. Diagnostic, I hope we'll learn very quickly what that means. But the submarine has been making some odd creaking noises. So you ask it to produce a diagnostic report in this case. All right, so we got a report that's probably coming out. The diagnostic report, your puzzle input. So let's start to write that stuff down. Remember, input, the algo, and the output is what we're gonna track for now. But the input is gonna be this diagnostic report. All right, let me give myself a little bit of music while I'm doing this. Cool. The diagnostic report music makes me think a little bit better. Cool. So we got our diagnostic report as our input. It consists of a list of binary numbers, which when decoded properly can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. So I'm gonna, list of binary numbers. I'm assuming there's gonna be 1s and 0s here. And it wants to check the power consumption. It seems like that's gonna go here. It's not something that is being input. The input's gonna be this list of binary numbers, and we need to check power consumption, which sounds like it's gonna be part of the algorithm, maybe even the output. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and epsilon rate. That sounds like output. Gamma and epsilon rate. The power consumption can be found by multiplying the gamma rate by the epsilon rate. Okay, so power consumption is actually the output here. Let me do all this since I already started. I'll go back in here, and it looks like we're going to be checking for power consumption. And that is actually going to be the gamma rate times the epsilon. Okay, that's helpful. And let's see if it's going to tell us how we're going to do it. So each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So each bit determined by finding the most common bit. I'm assuming it's a singular number here. For the example, given the following diagnostic report. So here's what our input is going to look like. It's going to be these 1s and 0s, okay, on different lines. That's helpful, a list of them. Considering only the first bit of each number, there are 5 0 bits and 7 1 bits. So 1, 2, 3, 4, 5 0 bits and 7 1 bits. Okay. So I think that's what they're talking about, kind of the first number in each of these binary digits. The first bit of gamma rate is 1. So the very first bit of gamma rate. So it sounds like we're gonna need to go through our list. And go through list. And it looks like we're going to be building our gamma number. and likely the epsilon number as well. And right now the algorithm is, we're choosing the most common bit for this gamma algorithm. So most common bit for gamma. And I know my shorthand doctor notes aren't amazing, but again, they're gonna help me be able to track this and figure this problem out. You write your notes in the way that you need to write your notes. But I'm kind of just talking through the information that I'm extracting when I'm reading this. Okay. The most common second bit of numbers in that diagnostic report is 0. So the second bit of the gamma rate is 0. So it looks like now the gamma is 1, 0, and it looks like we're building that up. So it looks like we're gonna iterate through these. It looks like we're gonna, determine how many zeros and ones are in each bit. So in the first location, the second location, third location, and we're gonna use that number to determine what goes next in our gamma rate. Okay. Respectively, most common. Okay, so we're gonna use the most common for all of these. So the gamma rate is the binary number 10110. So we're gonna look through each of the numbers in the column, determine which one is there the most. That will be the number that we add to as a part of our gamma rate. And then, or 22 in decimal. So it sounds like we're gonna have to convert to decimal. Okay, I think I remember how to do that. If not, we always have Google. The epsilon rate is calculated in a similar way. Rather than using the most common bit, we use the least common bit. So this is just kind of the inverse. This is good though, because if we have the gamma rate, we also will know the epsilon rate because it is the opposite. So it's 10110. So the epsilon rate should be 01001. That's exactly what it is. 01001, or 9 in decimal. So when you convert that to a decimal, you get that. Multiplying the gamma rate by the epsilon rate produces the power consumption. So again, we already have that here. Gamma times epsilon. Use binary numbers in your diagnostic report to calculate this. What is the power consumption of the submarine? This feels like it's going to be a bit heavy, and I've been doing this in Vim. I'm doing it in VS Code now because someone brought up the fact that the way that Vim does spacing and some of the, mostly spacing, it makes Go a little bit hard to follow, which I actually agree with. When I went back to watch it, I've been using Vim for so long. I didn't know that I agree with that, but I definitely do agree with it. So I'm going to do this one in VS Code, and so that we have everything right here, it'll be a little bit smoother, not having to exit out of our code all the time to see this run. So let's go ahead and let's make a day 3 folder. This is not how I would normally do it, but I'm going to do it the VS Code way today. And I'm actually going to copy our parse input go into here because it sounds like our parse input go is going to work for what we need, because it sounds like we have a list. So let's actually take a look at our puzzle input. It is in fact a list, and so we can we should be able to use this to do what we need to do. So I'm going to copy it into day 3, and I'm going to call it day3.go, not day 33, but just day3.go. So we have our file here, and in this directory, I'm also going to create our input.go. Okay. So we've analyzed it. We have we've kind of got our inputs. We've got kind of the way that we are going to get our algorithm to ultimately get to our outputs. And now we can get started. So let's do it. All right, I called out the wrong thing. Let's go into day 3 and input.go to input.txt. And I am going to go ahead and copy all of our input right into this file. There we go. So 1,000 items, that's helpful. We have 1,000 lines of things, as very similar to some of the other problems that we've done. Let's give ourselves a little bit more space to see. And it looks like it's, again, just a bunch of binary digits, just zeros and ones. And so if we take a look back at our Go code, all we did here is we set up a function that's going to allow us to pull in a file and read that file line by line. And it's going to take each of those lines and make it a new element in a slice or an array, if you're used to another language, and that we can iterate through. So we want to make something iterable. We want to be able to use our tools. We want a collection of data. And so we're using a slice. This one, we were doing stuff with integers. So yes, we're using zeros and ones. Integers seems like what we want to work with, but because we're going to be working with indexes here, like because we're talking about the bits and their locations, and like we can specify that bit via its location. I actually think I think right now the best way to do this is to work with these as strings. And the reason is because strings will allow you to, strings are a collection of elements. Strings are actually a collection of characters. And so you can operate with them the same way that you would operate with any other collection like an array or a slice. So if I have, it's pretty easy. If I have the string 0, 1, 1, 0, 0, 1, I can actually represent this first one. Let's say this was X. X at the 0 index would actually give me this first item. And if I wanted to get this 1 at the end, I can reference this at X as 0, 1, 2, 3, 4, 5. Or even X, this is the last item, length of X minus 1. And so I can use these index locations to actually access each of the items in a string, which is super duper helpful. I think that's gonna go a long way here. Maybe not. Maybe we'll get halfway through and it won't, but I think it will here. And so let's do that. I'm gonna change this so that it's giving me back a slice of strings instead of a slice of int. Do I need input int? Actually, I think I want this. I think this is the one I want to delete. I want to change this to string. And I don't need to do the conversion here, but I need to change this to scanner text. Then I can delete this. All right. And here, return a string. So this should give me back, it should read in my file now, and it should give me back a slice of strings. It should give me back an array of strings with each of those lines as a new element in there. And we're printing it out. We left that bit in there. So let's go ahead and let's run it. And clear. And I'll make this a little bit larger. And we'll do, are we in day 3? Go, run, day3.go. And there we go. We have a slice with all of these items in it. That looks right. I'm not gonna go into my input and really try to check against it. I think that we're good to go here. Let's make sure, just a quick check to make sure you have the right number of items. Let's go ahead and check the length. Check how many items are in this list. There are 1,000. We know that we have 1,000 items in our input file. So that is, we can feel good that we are getting our input. Cool. Let's move on to solving this problem. All right. So what we need to do is we need to actually go through each of the items in this list. And then we need to access every element, and we need to determine what is the most common binary number here. Is it 0? Are there more zeros, or are there more ones in this first bit of data, then in the second bit of data, then in the third bit of data, fourth bit of data? So let's start there. And the same thing that we've been doing all the time. If you want to iterate through a collection, for loop. That's why this is one of the reasons why we wanted to use Go, because there's only one loop type, for loop. So we'll just go ahead and we'll write a for loop, but let's create a function called day1, so we can do what we want. right inside of here. So day one will be our function, and it's going to take in our list as input, and that list is going to be a slice of strings. Excellent. Ultimately, our day one should output, what do we say our output was? It was our gamma times our epsilon. So it's going to return an integer, I hope. That's what we're going to need. So the first things first, let's go ahead and write our for loop. For I equals 0. And I encourage you to write these for loops out by hand rather than using the code snippets when you're not super familiar with them. Again, the muscle memory helps out a lot. I will start using the code snippets a little bit later, but muscle memory, I'm going through, if you're following along, doing it the way that I'm doing it, this does help you. So we'll iterate basically the number of times as things there are in the list. So we'll check the length of list and we'll run that many times. And at the end of each run, we will do an I++. So we're gonna add one to I. Okay, so this loop as it exists right now will run for every item in this list. Let's draw this out a little bit. So we got a list of these 0, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0. So we need a loop that's going to, it needs to check all the first digits first. So we're gonna access this at like list. We're actually it seems like we're gonna need some nested for loops here as I'm thinking through it. So we're gonna need to access each of these items by their index, but then we're gonna need to access, each of these letters. So like the very first time we run through, we'll need to look for list I of 0. The second time, list. I actually think we should switch it because we need to go this way as well as this way. I actually think we should iterate for the length of these first. So this length first. So instead of iterating over top of our input list, immediately we're gonna iterate this way first. Our first loop is gonna iterate from left to right, and then we will iterate down. So we're gonna do a little nested for loop here, and inside of here, maybe I'll be more descriptive with my I's and my J's, and we're gonna say for bit. And I hope bit is not a keyword here. And bit plus plus. Okay, so that's our bits. And then I'm gonna say for item, I'll loop through each of the items. So item equals 0. So actually, this is a change from lists to one of the items in the list. So any item will do. So I'll just use the first item, and because they're all the same length, because all of these lines are the same length, I can choose any of them. So I'm gonna choose the length of the first item. And so we're gonna iterate again across that. And then this one is gonna be the one that iterates over the list itself. And we'll try to draw this out because nested loops can be pretty darn confusing. And I'll do item plus plus here. Okay. Let's try this because I think this is what we want. And so if we are going to loop over those things, you know what? I'll just so we know it's working, let's do a funct.println and let's print out list at bit and at item. Okay, so for right now, this is returning an int. I'm gonna take this away. And actually, nope, because I don't wanna, again, forget about that later. And I'm gonna return 0 here. And so what this should do, I'm gonna use our test input instead of our full input so we can see exactly what's happening. So let's go grab our test input. And I'm gonna make a new file to pass in called test. I'll just call it test.txt. So we can work with a smaller subset of data and we can see exactly what's happening. It's a little bit more clear. So I should see 0111100011100. So we should see, you know, a list going down like this, and then these numbers in the second row, third, fourth, fifth. And so let's see if it prints out that way. Let's set it up to actually run. Instead of printing out this, we are instead simply going to run our day one function, and we're gonna pass in our input. And it doesn't look like we have any errors. And let's go ahead and run this. Go run. Okay. So index out of range, that's helpful. So we are iterating too many times. But what we're also doing, not only are we out of range, we're also getting 48s and 49s. That is because these are bytes. When you actually access an individual item, an individual character inside of a string, it is actually not a string data type. It's actually a byte. So I'm going to print out string. I'm going to stringify these things. And then our index out of range, if we iterate over all the items in lengthwise this way, while I is less than the length of the list itself, item plus plus, out of range with length 12. Hold on, let me check this really quick. So let's say it's 1, 2, 3, 4, 5. Actually, let's use different input. Test. Zero with length 0. All right, what are we doing wrong here? So I'm saying bit, then item, everything starting at 0. The length, let's say the length of the list is, what is it? 12. Okay, so we are saying bit is 0, while the length of this list, it's 12, but the length this way is 1, 2, 3, 4, 5. So 5 items. So as long as this is less than 5, we're gonna run, good. Then we're gonna say for item equals 0, while item is less than the length of the entire list, which is 12, go ahead and run. Does it run at all? Or does it fail immediately? It runs immediately. Index out of range 0 with length 0. Okay, so something has a length of 0. Gotta read your errors sometimes. List being passed in, input, test.txt. My file is called test.txt. Did I save it? There we go. You got to save your files if you want them to work properly. So I didn't save my file. So we get 001, 00, 1, 2, 3, 4, 5. It seems like it tried to go, because the last index of the item is -1. So we need to do the length of this -1. That makes sense. We just talked about it with our notes over here. -1. That seems right. Right there. No, not correct. 5, length 5. Length of list 0. -1. So the last one that it should get to is shouldn't run when it's 5. It should never run, which is interesting. List. So it is failing here, and the -1 didn't work. Let me see, does it work? 001000. It's not even doing that correctly. So let's see. Do I have something up here that's problematic? Takes in the list. So let's do ourselves a little T. If you're ever trying to figure this out here, make yourself a little T chart. And so right? Now I'm passing in list, I'm passing out int. I have values of bit. I have values of item. I have values, that's it. That's all I have. I have values for those two things. Cool. So if input gets passed in here, it's a list of strings. We are going to say, we're setting up this variable is 0. We're gonna say as long as this variable, this item is less than the length of the first item in the list. So this item right here, 1, 2, 3, 4, 5 minus 1, so 4. This is what we need to evaluate, 4. So as long as it's less than 4, no, that should still be fine at what it was, because it won't run at 5. It'll run at 4, but not at 5. That's okay. That's what we want. Add 1 to bit after each run. Another loop here. Item, same kind of thing here, but instead, we're gonna run this for as long, for as many items are in this whole list. So there are 12 items in this list. So that's how long we'll run this. So that's what we're comparing against there. And we're printing out the string here. But we're getting to a point very quickly where we are getting the wrong thing. So the very first time this runs, bit is 0. Bit is 0 on this run. Item is also 0 on the first run. Our output should be list at 0. Okay, so list at 0, the first item in list, which is this item here, at the 0 index, which should be 0. That's what should print out, okay? Then after that, this loop has to finish first. So it adds 1 to item and it iterates through this again. So when it adds 1 to item now becomes 1, but bit is still at 0. So we're still looking in the first string, and that's our problem. That's our problem. That is our problem. We're still looking in the first string, and we need to do item bit. Okay, that helped me already. That's why you do your little T-charts, so that you know what the output is supposed to be. And now when we run this, we get some output that looks a little bit different. So we get 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0. Okay, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0. So it does look like it went down and did it that way. We could put some breaks there. We could put some more probing statements to make sure we did it right. But a visual inspection, it looks like it's going straight down this row. Then it's going straight down this row. Then it's going straight down this row. So it should end in 0, 0, 1, 0, 0. Let's see, 0, 0, 1, 0, 0. All right. Now we can begin, I think, to add this up. Like I said, we could put some probing statements in to make sure that we're in the right place, but I think it's working properly. And so I can put a probing statement right, I'll put one right here, just so you can see. Format.println. I'll put one here that says moving to next bit, so that you can clearly see it's moving through the columns correctly. I'll save that. We'll run this again. And now you can see it goes to the first column of 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0. Stops there. Moving over to the next bit, we are at 0, 1, 0, 0, 0, 1, 0. And so you can clearly see here each of the columns when you're doing this. We still get to moving to the next bit because of where it ends, but it goes through the proper number of times. So I'll go ahead and I'll get this up out of here. Okay, so now we have the ability to scroll through our list and to go both through the entire list of items that were being input, as well as along each of the digits that are in the binary digit that was passed in, or the binary number that was passed in. So now we need to do a little bit of math. We need to see which item is there the most. So what we can do is keep it simple. I'm thinking of a couple ways, but we want to keep it very simple here. let's be explicit. I'm gonna set up a variable called zeros. Let's be a little bit more explicit. Let's say zeros. I don't know if zeros has an E or not, but whatever. You know, I'm not a great speller. We'll set zeros equal to 0 and ones equal to 1 or 0. Sorry, we set them both to 0. This is a scoreboard. This is a scoreboard for how many instances of the numbers we see as we're going through each of the columns, each of the bits here for these numbers. So as we, as a bit is a 0, we'll add to this list. So we can count up how many zeros are in this column and how many ones are in this column. And then we can do a little bit of comparison to determine which one is higher. So the way we can do this is, as we're going through, we're gonna say if, we've done if statements before, just so we're just using something different. If you never use a switch statement, we'll use a switch statement here instead. So we're gonna switch, and we're gonna switch on the same thing that we just were printing out. So we're gonna switch on list and item first and bit second. So it's gonna check that item. And this is kind of like an if statement, but case statements, switch statements work a little bit different. And what we're gonna do is, if the condition is if the item is a 0, then we are going to add 1 to the zeros. So we're gonna do zeros plus plus. Okay? And our next case is gonna be if it's 1. And if it's 1, we're gonna do ones plus plus. All right, so something we can use the if statement there, if else, if we needed to. But we're just trying something a little bit different here. And again, these are actually going to be bytes. So I'm actually going to stringify this as well. And I need to stop saying stringify. That's a JavaScript thing. But I'm going to kind of evaluate this as a string. I'm not converting it though. I'm not converting the type to a string. I'm kind of doing a temporary in place conversion to check against my data. The actual item is still a byte. And so if that's the case, we are gonna add up zeros, then we're gonna add up ones. So after it goes through and does all that, what I'm gonna do a format.print line, just so we know that it's working. Again, I don't wanna do too much work before determining my work is good or not. So I'm going to test it first. And I'm gonna set up a little scoreboard here. I'm gonna do printf. And set up a little scoreboard and say zeros, and %v and ones, %v, new line character, and we will do comma, zeros, comma, ones. All right, so this is gonna give me a little bit of output. It's gonna give me some output that tells me how many zeros were in that column and how many ones were in that column. Here is something that's gonna help us know that we are doing things properly. Each column, the columns, it's 1 character for each of these. There are 12 items in this. So my zeros and my ones must add up. Whatever comes out of this output, they must add up to 12. It must add up to 12. Okay, that'll be a good indicator. It must add up to 12. And we should see 5 of them because there are 5 columns here. There are 5 bits here. So we should see 5 of them if we did this correctly. Let's run that. All right, 1, 2, 3, 4, 5. That's helpful. Very, very helpful. Now, we already can see that something is wrong. The first time, 5 plus 7, that does equal 12. That feels good. But after that, we have 12, 12, 16, 20, and the numbers just keep getting higher. This gives me, think about it for a second. This instantly is giving me some information back in that we are continuously adding up our zeros and ones. As we finish up one column and we go to the new column, it looks like we're still using those same numbers. So we need to do something here. We actually need to reset the values of zeros and ones. We need to reset the value for the scoreboard after we iterate through an entire column, like top to bottom. We need to reset the zeros and ones value because we need to determine what is the most commonly occurring number in the second bits column, and then the third, and then the fourth. So we got to reset that value every time, but we want to reset it after the inside loop. So I think we want to do it right here, and we'll simply go zeros is equal to 0 and ones is equal to 0. So we'll reset it. So after it goes through the first item, it'll go through all of the items in the list. It will reset and start counting again. So let's go ahead and run this again. That looks much better. 5 plus 7, 0. I mean, it's 12. That's right. 4 plus 8, 12. That's right. So cool. I think we're doing it properly now. Okay. The way that we can use this information is we need to do a comparison. We need to determine, once it's done, we need to figure out what won to determine what to add to our gamma number. So I'm actually going to make a new variable here, and I'm going to call it gamma string. The reason I'm going to call it gamma string, and the reason why I'm going to make it a string, even though we're trying to return a number, is because in this case as well, working with strings is going to be easier. We're already utilizing that with the index, but also creating this is going to be easier, I think, if we use a string, because we can concatenate. We can append right to we can add right to a string. We can literally add one character or one string to another string. We can concatenate them and we can build a new string. And that's kind of what we need to do here. If we were using math, if we were using digits or integers, it'd be a little bit harder to build out this binary digit that this binary number that we're supposed to be building. So I think strings is going to work better. Again, I've been doing a lot with JavaScript, so sorry about the let there. Okay. So once we're done figuring out which one's higher, we'll simply do an if zeros is greater than ones, then we know that zeros is the more commonly occurring item in that column, in that bits column. So what we'll do is we will add to gamma string. So gamma string plus equals, if there are more zeros, we add a 0 to gamma string. We need to add a string to it. Else, we're going to just say we're going to add a 1 to gamma string. All right, I think that's correct here. And then what we can do is, why'd you do that? All right, we'll add 1 to gamma string instead. Oh, I did this completely wrong. And what we can do is, instead of doing this whole part here, let's format print line. Let's format that print line our gamma string. So I'm going to, because we know what that's supposed to be, because the example tells us what it's supposed to be, so we can test against that. Let's see inside of this, and let's simply print out our gamma string once everything is done. And this is actually going to print out our gamma string one by one. As things are added to the gamma string, this will print out the gamma string so we can see the progression of the gamma string, but we'll still get to see the final one as well. But all right, so let's run this, and there we go. So the gamma string ultimately is 10110, and did they say that was the right one here? The gamma rate is the binary number 10110. We have done it properly. Nice. It makes me feel better about myself, it makes me feel pretty good. So or 22 in decimal. So now we go to the next part. Now we got to do a little bit of decimal conversion. So if I remember how to do this properly, we might have to Google it, to be honest. But digging back, I think the way that you do this is, this decimal number is what, base 2? So let's say we have 1 0 1 1 0 1, sure, something like this. I think the way that you do this is, how many? 1 2 3 4 5. This is 6 and not 8. I think you take the item, you take the number that's in the spot, and you multiply it, because it's base 2, because it's ones and zeros. you multiply it by its index location, but the index kind of works in reverse in this aspect. So this is actually the 0 one here, and this is 1, and this is 2, this is 3, 4, and 5, and so on and so forth. But you need to multiply by the power of 2. This is base 2. So what I think we do is, I think we actually need to do, going from this end, is 1 times 2 to the power of 0 is how you get, you get a number for this. You'll get a number for this, and what is that? Anything to the power of 0 is 1, or is it itself? I think it's 1. So 1 times 1. So I think we're gonna get 1 here. I think that's right. I'm not a mathematician. Then the next one will be, then this next digit over here is actually going to be, because it's in the 1 place, is going to be 0 times 2 to the power of 1. And I think anything to the power of 1 is itself. So it's gonna be 2 times 0. So it's gonna be 0. And then we're gonna do, for this one here, I think we're going to do 1 times 2 to the power of 2. And so 2 times 2 is 4 times 1. So we're gonna get 4 here. All right. And then this one is gonna be 1 times 2 to the power of 3. So 2 times 2 is 4, times 2 is 8, times 1 is 8. So we'll get an 8 here. And we'll do our 0 here. So 0 times 2 to the power of 4, which is going to be 0. And then we get 1 times 2 to the power of 5. 2 to the power of 5 is 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32, times 1 is still 32, so 32, and then you add these numbers together, okay? So 32 plus 8, which is 40, plus 4 is 44, plus 1 is 45. I'm pretty sure that's how you do it, and I think they tell you that, well, this is with the numbers that I wrote here. I should have done it with just the example that they have, so I'll do the example that they have just to make sure I did that right. They have 1 0 1 1 0, so that'll be 0 times 2 to the power of 0, which is 0. So do 0 over here. Then with the 1, it'll be 1 times 2 to the power of 1, which is 1 times 1, which is 1. 1 times 2 to the power of 2, which is 4. This is 0 because it's 1 times 0 times 2 to the power of 3. And then the last number here is 1 times 2 to the power of 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 1, so 16. And so if you add those up, we get 16, 20, 21. All right, I got something wrong here. I did some math incorrectly. That is 1 0 1 1 0 1. Oh, it's itself. It's itself. That's actually a 2. So 22. All right. So there we go. That's how you do it. So we have to implement this same logic to convert this stuff to decimal. Let me think about how we're going to do that. So let me first, because we're doing this correctly, let's finish this out. And instead of printing out gamma string, we need to return that gamma string. But gamma string, we need a number. Gamma string is a string. We should, are we gonna need to, let's actually leave that as a string. Let's actually leave that as a string. For now, I'll keep this as return 0. We have our gamma string in here. Let's make another function really quick. Let's make a function that's going to be a binary converter. Binary convert. Make it a little bit larger. So yeah, let's do a binary conversion here. And this is gonna take in our gamma string, okay? So it's gonna take in our, I'm gonna say it's gonna take in our binary string just so we can know how the data is flowing, which is gonna be it's gonna be just a string. And the output from this, because we're converting this to a number, we would like to, return an integer. So we actually want to return that decimal number that we have right here. So we're going to return an integer from this. So the problem with this is that we actually need to work backwards. So again, let's say we have the example that they have in here, which is 10110. We actually need to work this way. So this is going to be kind of like an inverted for loop because we still need to go through all the items. For digit equals, so if you want to start at the back of this, you start at the last index. The last index is always length -1. So I'm gonna start there. I'm gonna say digit equals the length of binary string -1. So that is the final, that's the last index there. I will do while digit is less than or equal to 0. So we're gonna count down instead. We're gonna count from the last item down to the first item. So I'll say less than or equal to, I think. And we will do digit plus plus or digit minus minus because we need to go down instead. All right, and to go through, we need to do a couple things. So as it accesses the first item it's gonna access, again, will be this 0 at the end. It's a string and it's actually gonna be a byte. So we're gonna need to convert that into, a integer. And when we convert it into an integer, we're gonna need to do some math against it. So what I will do is I'm gonna set up, just so we have something to work with, I'm gonna set up a variable called, it's called num. And it's gonna be an integer. I don't really need to do this. I was trying to be explicit with it just so people could see what was happening. Because sometimes it's confusing when you do a variable creation inside of a loop because it looks like you're not allowed to do that because, you know, it's already been created. So I'll just do this. So I'm gonna first do a conversion. I'm gonna convert the item that we're currently on into an integer first so we can work with it. So I'm gonna use the string conversion package that Go has inside of it to do that. And I'm gonna basically catch num. I'm gonna throw out an error. And that's gonna be equal to stringconv.atoi. So that's gonna be ASCII to integer. And this takes in a string and gives you back an integer. So because we are gonna pass in a byte, I've gotta convert it to a string. And we are gonna pass in binary string at the digit index. Okay, so we're using digit to track the index location. So we're gonna pass that in. And once we have it, we're gonna do some math here. And the math that we're gonna do, first, remember that the way that I just did it by hand, remember we added these numbers up. All the numbers that are over here, we added all of those up. So let's have a, let's call this decimal. Let's make a variable called decimal instead of equal to 0 so that we have something to add to. And so I'm gonna say decimal plus equals, so the calculation again is whatever the value of the item is, of the binary digit is. So it's gonna be the digit times the current digit times base 2 to the power of whatever index it is, but from the opposite direction. So Go works a little bit differently for exponents. So first I'm gonna do binary. Oh no, I don't even do that. We have it as num. So num, because we already converted it, times 2. Actually for Go math dot pow. So we're actually All right, so I'm gonna use the math.power function because this is how I know how to do it. There's probably a better way to do this, but the problem with the power function, the math.pow function, is it works with float 64s rather than integers. So I'm gonna need to do a little bit extra here. That's fine, but this is how we're gonna do in Go. This is how you do exponents, I'm pretty sure. Like I said, maybe this is a better way, but this is the way that I know for now. And so I'm going to, math.pow takes in two things. It's gonna take in the first thing is going to be where x is the base exponent. So 2 is gonna be the first item, and the exponent is going to be, the exponent is gonna be, oh, we need another variable to count our reverse indexing. We are moving backwards, but the index doesn't change. The index number from the back is still the same thing. So we're gonna, I don't know if index is a keyword or not, but I'm gonna create one called index. Let's just do I in case index is a keyword. We know that I is not. I is gonna be equal to 0. So we're gonna start at 0, which is the final indice. And what we're gonna do is we're gonna, to the power of I. So 2 to the power of I times whatever number we have. I know it's a little bit confusing, but that's what we're gonna do. The problem is this needs to be a float 64. I think I can just do this, I hope. That would be nice if I could just do that. Why are there 3 here? 1, 2, 3. Okay, that's right. All right, takes in a float 64. I might also have to convert this because I don't know if I can just do that math. But gonna find out in a second. And that is gonna end up giving us our decimal number, and we are gonna return decimal, which is an integer. And I don't see any errors. I don't see any errors. That feels a little bit weird, but let's go ahead and convert our gamma string up here into a decimal. I'm going to format.print. I'm gonna call binary convert, and I'm gonna pass in gamma string. And I wonder if that's gonna work. There's no problems, which feels weird because I'm a little bit unsure about what I've done. This is confusing me a little bit, but let's see. I got a %0. That is, you know, that's seems like it seems like it ran. Let's see if we can modify it to actually know what's happening here. Let's do, after we add to it, I'm going to print out decimal. So we can see what decimal is. Oh. Convert. Gamma string, binary string. It's not giving us any print lines on decimal. Here, I wonder why that is. 0%. Nice. Let's do this. Float 64 and float 64. And maybe I could have just made num and return a float 64 as well. Operate mismatch types, float 64 and int. Oh, because I'm inting all of this. Oh. Why did I do all that then? Well, let me I already typed in all this stuff, so let me try that instead. And let's see if this gives me a better, nope. Does not give me a better output. So let's see, I'm printing in the output of calling binary convert. I'll just call binary convert instead of putting out the stuff inside of it. We hit binary convert. Gamma string has length. Oh, this never runs. That is why. I might not need to change all the things that I needed to change, but I'm checking while this is greater than or equal to 0, not less than or equal to 0. There we go. Okay, so that gives me 0, 1, 2, 3. That makes me think that I messed up. Oh, actually, what did it give me? 0, 1, 2, 2, 3. 0, 1, 2, 2, 3. Let's see. That seems incorrect. 64. 0 should be first. What is the value that we're supposed to go? We're supposed to get 22. It adds them all up. Float 64 num times math pal base 2 float on I. Oh, got it. We are not incrementing our I here. We're using this I as outside of the for loop. We need to increment that I there so that the I in here goes up, so that the actual exponent does increase. And there we go. We get 22 exactly as we were supposed to get. Okay, so now we've written a function to convert a binary string, a binary number string into an integer decimal value. So that's good. We'll do that successfully here. So we're gonna get that number back, and really we don't even need to do, we're doing everything in this function. So now we're able to convert that value into this number. And so ultimately this is gonna be our actual gamma number. Here's what I'm gonna do. We can hack this now. We'll say gamma equals this. We already made gamma up here. No? Why doesn't it like that? Bar gamma float 64 gamma. Oh, declare we're not used. Okay. So gamma is this, and we also need epsilon. And our epsilon value also is going to need to go through binary convert as well. And it's going to be epsilon string. Even though it's not something we have, I think it's going to be epsilon string. That feels right. We're looking for gamma string. We're looking for epsilon string. So how are we finding our gamma string here? Okay. So if we have our gamma number, our epsilon number is the inverse. So we could write something to just flip the numbers. I am going to say zeros are greater. Oh, all we gotta do now is make something called epsilon string for epsilon string, which is also a string. And at the same time we add to gamma string, we're gonna add the opposite to epsilon string. That's how we do the inverse. So epsilon string plus equals 1 here. And epsilon string, I thought we were gonna have to do more there. I think this should work. So that'll give us both strings. And then once we have both strings, we will pass them into here, into the binary convert, which should give us some digits, and we should be able to return gamma times epsilon. That feels like it's gonna work. The problem is that's gonna be a float 64, which I'm okay with. And I think we may have just solved part 1. Let's save it. Let's run it. There's a lot printing out. Oh, because we didn't actually call the function that we needed to call. We can remove those print statements because it's a little bit confusing. Remove that one. We're printing out anywhere else? Nope. Okay, so we're getting our input. We're calling day 1, but we need to format. Let's actually save it to result instead of doing that. Let's save result. Result of this. And let's go ahead and format that print result. All right, let's do it. 198. So this is the value using we're still using this test input here, okay? Because we have something to test against over here. The value is, you can't see it because my face is in the way, but the value actually is right there, 198. So that is the proper answer when we're using the test data. That's good. That makes me feel good. So now we can do it using our data. Let's move this back down. There we go. And the way that we can do that is simply by changing the name of the input file. So we were taking in test.txt. Let's take in input.txt. And let's run it. And we get, what was that, 1, 2, 3, 738,234. Let's see if we've done that properly here. Submit, boom. We got ourselves another star, a little bit more complicated than anything that we've done so far. So the progression of difficulty is happening. So take a quick break and let's hop into part 2. All right, break done. Got a little bit more coffee. Let's do it. Let's hop into part 2 and see if we can grab this second star. These are getting bigger. I'm gonna have to start taking a look at these beforehand, so that we're not spending 2-3 hours each walkthrough. But they're fun. They're good. This feels good. I'm interested to see day 4 now. I'm more excited about it. So part 2. Let's dive into it. Let's analyze it. Let's figure out what our inputs and outputs and algorithms need to be. Inputs, algo, output. Okay, so next you should verify the life support rating, which can be determined. So I think what I want over here is life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. So oxygen rating plus, or is it multiplying? Not plus, but instead multiplied by the CO2 rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. So same input, cool. Finding them is the tricky part. Both values are located using similar process that involves filtering out values until only one remains. All right, we're gonna have to do a little bit of filtering here. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. So same thing, looking at the first bit. So we may be able to use our same code to do some of this. Then, I'll write some of that down because this is actually a lot. So our input is still our diagnostic report. And our algorithm is going to be, I'm going to put just filtering here. Okay. first bit, keep only numbers selected by bit criteria. For the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. So we're going to be taking the full list of things and we're going to get some criteria which we need to filter on, and we're going to need to filter on our own. It seems like I don't yet know what the criteria is, but it says considering just the first bit. So it seems like maybe we'll take the greater or less than thing here. Maybe, I don't know. If you only have one number left, stop. This is the rating value for which you are searching. That gives us some information there. Stop when only one. So we're going to trust that this data is going to be given to us in a way that we'll only have one. That'll be helpful. Otherwise, repeat the process considering the next bit to the right. So when we get to the end, we should only have one. The bit criteria depends on which type of rating value you want to find. That's helpful. To find the oxygen generator rating, determine the most common value. So most common gives us the oxygen rating. So same thing that we did before. We could still use our method of counting things up. That's helpful. If they are equal though, keep values 1. So equal, use 1. The CO2 on the other hand is least. Least common is going to be CO2. If they are, I'm assuming if they're equal, we're going to use 0 in this case. Yes, if they're equal, use 0. Okay, this is a good one. I like this. I like this a lot, actually. So for example, they give us an example. Start with all 12 numbers. Consider only the first bit of each number. There are more 1 bits than 0 bits. So keep only the items with the 1 bit in the first position. So so after the first run, we won't have any items in our list anymore that doesn't have a 1 in the first position. So everything that starts with a 0 is out of there. Then you move to the next digit. And you do the same thing with that digit. Okay, this is finally add the life support rating, multiply. So we're gonna do the same thing here. We're still gonna need to convert to decimal. What are we converting here? Because it doesn't sound like we're building a number like we did last time. Oh, the oxygen generator rating, and the rating is the last. The rating is the one thing that's left over. So it's going to be a number from the list. It's going to be a list number, and we're going to have to convert that into a decimal the same way that we did it before. It's just going to be a shorter. Well, no, it's not a shorter number. It's going to be the same exact thing. We're just not building a number this time. All right, this is not crazy easy, but let's do it. Let's knock this one out. Here's an example. We're gonna use our test data again, knowing that the value is gonna end up being 230. You know, we can use that smaller data set. So day 2, I'm trying to figure out, or puzzle 2. I'm trying to figure out if I feel like breaking this up so that we can reuse this stuff, or just copying what we have and just you know, kind of retyping what we did and kind of rehashing these things out. I don't feel like changing the date. I don't feel like I would have, if I did that, I would have to rip stuff out, create new functions, and modify my day 1 function to use those functions. I don't want to do that. I'm just going to yank all of this, and we're going to make a function for day 2. And this is how it's going to differ. Day 2 is also going to take in the same list. It is also going to return a float 64. It's going to return a float 64. We can keep all that here. We no longer need a gamma string or an epsilon string. Instead, we need the CO2 rating. Say we need a CO2, CO2, and we need an oxygen. Yeah, let's do CO2 and oxygen. Maybe we won't need to use those, but I think everything else still applies. We still need to iterate through everything and determine ones and zeros. But now we're gonna need a filter now though. Instead of doing this, building the string, we're gonna need to filter based upon a value. So I'm gonna make another function called filter. Filter is going to take in it needs to take in a list of strings. And so I'm gonna call this list here again, and it's gonna be a list of strings. And it's gonna need to do the work of filtering. The algorithm is gonna be removing all the things that don't match the criteria, and then returning a list of strings. It's gonna take in a list of strings, filter out stuff, and return a list of strings. And so it's gonna need to know what to filter on. So I'm gonna also pass in criteria. And that's gonna be a string as well. Maybe it'll need to be an integer, but for now, I'm making a string. So I'm gonna take in the list that I wanna filter, and I'm gonna take in the thing that I need to filter it on. That makes sense to me. And let's implement that logic. All right, so we need to iterate through. We might have to do another loop again, another like double loop again, maybe. So we're going to do for. All right, let's draw this out really quick. Let's say we have a list of these strings, and the first string is 0, 1, 2. The second string is 1, 2, 3. The third string is 2, 3, 4, something like that. We want to first. Oh, you know what? We don't need to do anything fancy. Okay, we're already doing the work of going through each bit location here. We can add in the filter right in, right here. So we actually don't need to worry about the placement. But if we need to pass in the index as well. So we're taking three things. I'm just gonna be an integer. We're taking three different things. Which is going to be the list that we would like to filter, the criteria that we're going to filter on, and the current index, so we know which number, we know which bit to check for to do the filtering. Okay, so what we're going to do is we're going to iterate through our list. So for I equals 0, while I is less than the length of the list, I++. What we are going to do is we're actually going to make a new list to return. We're not going to do any deletions of our list or anything like that. We're going to make a brand new list to return. So I'm going to do var filtered list. And that is going to be a slice of strings. It's going to be an empty one here. And what we're going to do is if the item in the current list, so if list at the index location that was passed in, so index. So let's say we're checking in the first spot, that index will be 0. If we're checking for the third spot, that index will be 2. And so we'll say if the item that we're currently on, if the index that we're checking against, if that is equal to the criteria. If that's true, if it's equal to the criteria, we are going to go ahead and we are going to add it to our filtered list. Filtered list equals append. We use the append method, filtered list, and we want to actually add that thing. Forgot this is going to need to be a string here. Or is it? No, we add the whole string itself. So we add list I. Yeah, so we're gonna add list I. We need to stringify this though, because we're checking one individual digit or character, not digit. So we're gonna add that to our filtered list. If not, we're not gonna add it. And when that for loop is done, we'll go ahead and we will return our filtered list. That feels like a good filtering thing. So now what we're gonna need to do though is we need to modify our day two, did I call this day one? I should call it part one, but our day two function here to work properly with what we have. So if there are more zeros than ones, okay? If there are more zeros than ones, instead of adding that item to the gamma string or the epsilon string, we need to filter based on zeros. So if zeros is greater than one, I need to call our filtered function and to call our filter function, and I need to pass in our list, and I need to save that back to the list, which is fine. Is that gonna be a problem? Might be a problem, but let's see. All right, we're gonna start to filter stuff out of our list. So list is now equal to filter list. That doesn't work because I didn't pass in the right values yet. So we're filtering based on, if zeros are greater than one, we're filtering based on zeros. Okay, and our index is going to be bit. It's gonna be bit and not item. It's gonna be bit because that's the thing that's working on the bit index. So we're gonna pass all those things in and we'll filter on zero if that's the case. We can do the same thing here. That we did in day one or the part one. We can do var CO2 oxygen list, which is going to be a slice of strings, and we can also make a CO2 list, which is also going to be a slice of string, because one is using the most common and one is using the least common. Again, we can do them all in one line here. We do them all in one line here. So if this is the case, we actually have to change this up too. We don't want to make an empty list. We actually want to set these equal to list. So basically what we want to do is we want to start with one big list that's the same for both of them, and then depending on our filter, we need to remove from only one list. If we only use the list variable, then it's not going to work properly because we're going to be filtering on two different cases from the same list, which is problematic. So two different lists, and we're setting them equal to the value of lists. And this is, we're creating these variables, so we need the shorthand walrus operator there. All right. Now that we do that, we will say if zeros are greater than one, I think oxygen list was the one that is more than oxygen using the same. Yes, oxygen uses the most common and the CO2 uses the least common. So if zeros are greater than ones, Then we will, the oxygen list, pass in oxygen list to be filtered. And we'll filter that on 0. And in this case, the CO2 list will also be filtered, but by 1s instead at the same time. Filtered by the CO2 list, comma, what else does this need to take? Filter that by 1, and same thing in the bit. And should 1s be greater than 0s, we simply need to do the inverse. We don't need to do anything fancy. We don't even need to check for it, but we simply need to do the inverse. And so if this is the case, this will be filtered by 1s, and this will be filtered by 0s. All right, so that's gonna do our filtering for us, but we also need to do something that it brought up here. We can't have it, we don't really want it to keep checking because, well, it can keep checking, that's fine. But we want to stop when there's only 1 left. Only 1 item left. That's something I caught when we first read it. So we will know. If we do this at the same time, one thing that sucks about this is if we do this part at the same time, then it should still work. But we lose the ability to just stop. Let's go forward with this. If we need to add in something, we will, because it might take one longer to get to the end goal than the other. And all we'll do here is, after we get down to the 1 item in the list, it's going to be a string. It's going to be 1 string inside of a slice of strings. And we are going to need to convert that into a number. So we're gonna binary convert. And so what we can do is, not give them an echelon. I'll call this oxy rating, and I'll call this CO2 rating, and we'll convert this what do we need to convert? We need to pass in oxygen list. There we go. It knew we needed to take in the only item that's in there. So oxygen list 0, because there should only be 1 item in there. And here, CO2 list of 0. And then we return these 2 things multiplied together. Oxygen rating times CO2 rating. Woo! This is a little bit more in depth. I don't know if this will work. We have var CO2, var oxygen. Do we need those? Do we use those for anything? We didn't. I'm gonna delete them. All right, I should put in some probing statements, but I'm gonna YOLO this real quick. And I'm going to change this to be result 1. And we'll change this to be result 1. And let's also go result 2. It's equal to day 2. Pass in our input. And again, we're gonna actually do the test input because we can confirm it's working because we have the proper results. All right, let's run it. I don't think it's gonna work, but let's run it and let's see what happens. There we go. Index out of range with length 0. That sounds like we're not something we did before. We're not incrementing something properly. Plus here on binary convert. It's not a big deal. What do we have new that we just did? Filtered lists. Does it tell us where? 98, 130. Oh, I wonder, okay. I wonder if CO2 list on 98 is not actually, yeah, day 2 input. CO2 list in this case doesn't have anything inside of it. CO2 list equals filter. Let's see what these values are before converting them. And I'll simply return 0.0, and I'll comment both of these things out so that we can see. I'm gonna have to put in probably a lot of stuff here. Oxygen list. And let's go CO2 list. And see what we're getting here. CO2 list is probably empty or 0. So oxygen list is 0, CO2 list. Well, oxygen list is empty, CO2 list is 0. Or is this the actual, oh, so we get something for that, but not for this. What is this 0 though? What's being printed out on 0? Oh, the result here. Okay. So we are getting a value for oxygen list, but not one for CO2 list. Filtering on oxygen list, filtering on CO2 list, 1001. Ah, yeah, we need to stop. I wonder, there we go. Let's put a handler in here. Let's see. I want to see how this filter is happening. Printf, CO2 filter, and B. I want to see how things are getting removed. Theoretically, it shouldn't remove the last item. So we get here, so it's filtering on 0 at first. Oh, you know what'll help? Well, we know what our original input is. Our original input is all of this, and so it must filter on 1s on the very first go because only 0s are left. And there's 1, 2, 3, 4, 5 here. All right, so our output is 1, 2, 3, 4, 5. Okay, that's helpful. Then it must do it on 1s because only 1s are left. Then when it does the addition and subtraction, okay, all right, it needs a handler here. So let's move around our code a little bit to work with this. This is also why you should plan out your code a little bit, but this is good. Because now what we can do is, zeros and 1s. I'm trying to think if I just want to add more if statements, or if I'm trying to think of a clever way to do this without restructuring a ton of code. Again, we just need to put a handler in here to not to stop when there's only one item. Let's actually do and zeros are greater than 1. What should I check for first? Should I check for length first, or to maybe I'll put a handler in the filter function here. Still going to do more work than it needs to do, but I'm basically going to put in the filter function if the length of the list is 1, go ahead and break. Go ahead and break this loop so that you can return filtered list. Filtered list equals list, and let's go ahead and break this loop, and then it'll just return it every time. This is hacky. This is definitely not the most elegant way of doing it, but it's a little handler so that we don't delete all the things that we do. And so we actually get some final numbers here. We retain some numbers with our code, and we can actually again check that against what we got in our example here. And all right, we have these. So 0, 1, 0, 1, 0. So we got 0, 1, 0, 1, 0. That's what we got for our CO2. And for our oxygen sensor rating, we were supposed to get 10111. We got 10110. This makes me think I think it's this. I think it's these. I think there must be a situation where there's an equal amount and it's not using the right one. We solve that. If zeros, okay. The easiest way to solve this without having to restructure it is, because right now we're checking if one's greater than the other, and in all other scenarios we do this. We're actually going to need to do an else if ones, excuse me, if ones is greater than zeros, we're gonna do this. That makes sense. And then an else. We can do an else here for equal, because we need to take this and it says when they're the same, for oxygen lists use ones. Oh, actually, for oxygen lists use ones. For CO2 lists, use zeros if they are equal. This should have worked. I think this else works fine. So if zeros is greater than ones, do that. Makes sense. But if they're equivalent, oxygen list should get 1. And CO2 list should get 0. That is right. I actually don't think we need this. Hold on, I might have done a little bit too much too soon. But we are getting, let's actually look at this. Got it. I got it. Just that fast. Just that fast. I got it. This actually would have been a hard one to catch. I'm glad my mind followed that properly. I think I got it. The reason this is happening is, are we checking against the right list and not the original list? No, we're filtering the right list every time. All right, we got to put some statements in here to see what's happening. We're off by 1. I'm about to convert it, but I need to figure out why it's giving me this one. So what place, I guess, what place did it get to? All right, so if you go through the example here, in the second position, we got 1, 1, 0, 1. This is what we actually ended up with. So that was after the second spot, because consider the second bits of the remaining 7, which were 0 bits. So give us these 3. Then the third position, 3 of the 4 numbers have a 1. So we got to actually keep these 3, and our number's still here. In the fourth position, 2 of the 3 numbers have a 1. So we chose 2 of them have a 1 in the fourth position. So we filtered on that, which doesn't change anything, or it did in this case. There were more there. And then the last one, in the fifth position, there are equal number bits, 0 and 1. Okay. 1 of each. Keep the number with a 1 in that position. Yeah, that seems right. It seems like it would have got to this last position here, and it would have checked. It would have said is, where are we at here? It would have said, is zeros greater than 1? No, zeros is not greater than 1. Or because is 1 greater than 1? Because they would have each had 1. It would have said no. So it would have filtered oxygen list based on the 1s. So here's what we'll do. We can actually do another statement here. Format dot printf. And what we'll do is zeros, 1. And we'll do a little scoreboard here, and we'll put the zeros first with a dash, and the 1s, so we can see how much there were, to make sure that they're not the same. See that we matched properly. And here we'll do zeros, comma 1s. And then we'll take this and we'll say ones 1 or was equal. All right, and then it should match this, same thing, zeros and 1s. What else do we need to see? I also want to see some filtered lists here. So I want to see format. Let's add new lines here. Let's add new lines here. And let's do a format.print line. I want to see forehand. I want to see both lists. I want to see oxygen list, and I want to see CO2 list. And then when these actually happen, want to see them again so I can see how they're getting filtered. Hopefully this will, it's gonna suck. Can I do, will this work if I do oxygen, the space, comma? Yeah, that's a little bit helpful. CO2, comma, and lastly, I know I type slow, I'm sorry, comma. This is gonna give me some output. I don't really like to do this all the time. There are better ways, but for what we're doing, this is gonna help. So, oxygen list, 1's 1, okay, with a score of 5 to 7. Great. So then oxygen is this, CO2 is this. I want to get down to where the last go. CO2 has been right since all the way right here, but oxygen is still going here, and it's still got both of the right. It's got what we got, and actually has the other option that should win. Is that before or after? This is when the ones win. The ones win here, and after the ones win, filters. Doesn't remember anything. Then the zeros win. 7 to 5. Yeah, okay. Here is where we're going wrong. Look at what we're checking. Every time we're getting 12. The number should be decreasing every time we filter stuff out. So we're checking against the wrong thing. So where we gotta change the thing that's doing the counts for the zeros. Okay, so that is actually this. We need to be, for day 2 at least, we need to be going through oh, this isn't gonna work. This is not going. This isn't gonna work. Because we'll need to pass back. Like, we're going through the list and we're checking against the list. We will need to check the list again to see if ones, we'll need to check the list that's coming back from this. We got to move this around to, we basically have to start iterating over that instead. So here's what I'm gonna do. Here's where I'm calling this audible. I should think about this for longer, but again, we're just trying to get to the end here. And so what I'm gonna do, I'm gonna accept another parameter, which is going to be the rating. Like, which rating are we checking against, which is gonna be a string. So whether it's CO2 or oxygen list, I'm gonna make one list called filtered list. They already used that somewhere. That's equal to list. I'm gonna iterate over filtered list. I don't think this one will matter, but I'll just, so it's not all weird, I'll make it anyway, and I'll iterate over filtered list instead of list. I've already committed, so I got to keep going with this. If this is the case, delete this, delete this, delete this. I don't care about doing one or the other here. I care about, ooh, even nicer. I care about doing one or the other here, depending on, now I need a whole nother if statement block here, but we'll say if the rating that was passed in, is equal to oxygen. So we check for the oxygen rating. So I'm going to change this day2 function to actually be it's going to be a function that we're going to have to call twice. So if the rating is oxygen, then we will do this stuff. Zeros are greater than 1, and it was oxygen, then we are going to we're only going to filter on the oxygen list. And so we can take this part off. But I'll keep that there for now, just so I can, so I don't forget anything. Okay, so if the oxygen is, if that's it, whoa, why'd that happen? I clearly hit the wrong character here. There we go. If it's rating, other one, let's close this. That closes that if. This is this if. We'll do an else. Same thing. We'll take it all. All right, so now I can delete, whoa, undo, there we go. Now I can delete some extra stuff here. So if this is oxygen that's passed in, I can not do anything with the CO2 list. And I can do filtered only. List, filtered list, and same thing here. I hope this works. I think it will though. Okay, so if it's oxygen, I need to, filter on 0 if the zeros win, because it's most common, or send a filter on 1. And so now I can change this to greater than or equal to. I'll change this one to greater than or equal to. And I'll only modify the list that matters. Again, I could actually do this all higher up, so I wouldn't need to do all of this checking down here. But again, I think this is just gonna be the fastest way from where we were to get to this here. And so I'm gonna delete that one and that one, and change this to filtered list as well as this. So a single filtered list so that our function can remain the same. Filtered list and filtered list. So now we're not going to get both items. We're going to get a single item based off which list we're trying to go for. Delete those. And what I can do here is I can simply return the filtered list. Filtered list 0. Or no, I'm not gonna do that. I'm going to same thing that we did up top. We're going to only return 1. And we will do binary convert filtered list 0. And we'll call this the actual, it doesn't matter what we call it. Result, because we still need to multiply later, but I'm going to return the result. which is going to be the return result is going to be an integer. Is that what I'm returning here? A float 64. Oh, it's going to be a float 64. So that makes sense. So we'll return that float 64. So here's what we have to do now, though. We've got to call two functions to do this. So we're going to call day 2, and we'll call it with oxygen first. Okay, and then we'll call it, this is all over the place. Sorry about that. Oxygen, and we'll call this with CO2. Yeah, CO2 down here. Same thing, day 2, and we'll call that with our input. And we'll call that, we can call it with anything else because of the way that we wrote our check, but I'll call that with CO2 as a string. So this is gonna be our rating that's passed in. And what I'll do first is just make sure we get some numbers back. Actually, I'll just multiply them here. I'll multiply them together in this print line right here. And I made a lot of changes. There aren't any problems syntactically right now, which is helpful. And I'm gonna run it, and I get 198. I get 220. So 198 from the first function, 220 from the second function. That looks familiar, and I'm close. It's 230. So there's something we're doing. There's something we're doing a little bit off. So let's get a little bit more information. It says that rating should be 230 for the test input. All right, let's make sure let's see what we're getting back before we multiply them together, because they give us that information as well. Let's go ahead and, instead of multiplying them, let's print oxygen, and let's print CO2 to see which one of ours is off. CO2. It should be 23 and 10, 22 and 10. All right, 22 and 10. And so it sounds like we're still getting the wrong, it sounds like we're still off by 1 in one case, which kind of sucks because that's why we changed all of our code. Let's make sure we're doing our day 2 part right. Day 2, if it's less than or equal to 1s. Oh. Filter on 0. If zeros is greater, filter on zeros, but I actually think I need to remove the equal sign, because if it's not oxygen and it's CO2, so for oxygen, if zeros and 1s are equal, it should filter by 1s because that's the higher one. And I think that will give us our, no, not quite. Okay. So close, we're so close. We're getting 22 instead of 23. For that, we got to figure this out. One more second. Let's see. I'm mad I switched all that up and it didn't just work immediately, but you know, sometimes that's how it works. Let's do, what information are we trying to get? We're trying to get why our first number, our oxygen rating, why it's 22. So before we binary convert, let's first check our check filter the 0. Let's see what we're passing to binary convert. Make sure we get that information, and we're passing in the first time, again, we're off by 1. The last case is where it's not matching. So let's say we get down to the last 2. We're checking against our filtered list in both of these cases. Okay. Checking against filtered list. So we're going through the length of how many items are left in there, and we're counting up zeros and ones. Let's say they're equal. Let's say zeros and ones are exactly equal. And so we're on oxygen, we're on the 5th one. It'll say, are they equal? No, they're not. So it's gonna drop down to else. It's gonna filter on 1, which should be correct. Length list. Plus 1 filters break. List I plus the index equals the criteria, which should be 1, because it should drop through the else. It should pass through. That's very, very frustrating, actually. Plus, we only need to put some stuff in for oxygen. Let's say format.printf. Format.printf. Let's do filtered oxygen list. Filter oxygen list, and let's print that out. Let's do filtered list. Let's also do zeros, %V, ones, %V, zeros and ones. Let's take that. Whoa, redo. B, let's yank it. I want to see it everywhere. So we know which one, zeros and ones. I want a little bit more here. Zeros and ones. I want to say filtering by 1. Filter criteria 1. Here I also wanted to say dash filtering criteria 0. And what else do I want? I want to know what the filter criteria is. Can I see that? After filtering ones, V, new line. Let's go ahead and let's look at our filtered list. It's that here as well. Let's go ahead and get new lines everywhere else so that we don't get super duper weird, crazy output. Lines. All right, I think this will give me enough information to figure out where we're going wrong. So close, so close. All right, let's run this. All right, filtered oxygen list here to start. Zeros 5, 1, 7. Filtering criteria 1. Filtering after filtering ones. Makes sense. We kept all the ones here. There are no zeros here for the first location. Filtered oxygen list, same list. We have the zeros 1 again, 5 zeros. So So 7, that's the problem. 1, 2, 3, 4, 5, 6. All right, 7 items in the list. That makes sense. 5 zeros, 2 ones. So filtering criteria is 0 for the second slot. After filtering, oh, we have something wrong here. Zeros, ones won the first time, filtering on ones. Zeros are 5, ones are 2. Oh, after filtering on ones, so, oh, look at that. What the heck? Filtering on ones, that means only one should be in the second spot. Hold on, let me add a little bit more. I think I see what's happening here. Let me also say filtering on criteria 0. On index %V. And that's going to be bit. So I can see what bit it's currently on. What's happening here? Comma bit. All right. A little bit more, a little bit less confusing. Hopefully our output will be. So filtering on criteria 1 on index 0. So we only get back things that have ones left. Filtering oxygen lists. That's after it's been filtered. Great. Then the zeros win. So we should filter on 0 on index 1. So index 1, we just get items with zeros back after the filter. That's good. Zeros lose, so ones win. We should filter on 1 on index 2. Index 2, we get ones only in this spot. Those oxygen list. Then ones win. 1 on index 3. So index 3 is right here, the 4th item. We filter on that. Great. After filtering, we'll start with this. Zeros are 2 for 4. Oh, that's wrong. How is that right? There are only 2 items. It's saying that the zeros win that. That is wrong. 1, 2, 3, 4, 5. 5 items. We were on the 3rd index. We should be looking at the 4th spot right here. It's saying that the zeros won that. So it's filtering on zeros for the last one. That seems random. Here, I know it's not random, but seems like it's working fine up until then. After filtering the ones on index 3. So it's when it hits the last spot. When it hits 4, why is it counting 2 zeros? 1, 2, 0, 1, 2, 3, 4. Index. All right, so let's look. Is there a case statement? It seems like it worked up until that point. All right. Zero, add to the zeros. If it's 1, add to the ones. But in this case, it is saying it got 2 zeros. How did it get 2 zeros from this? From the filtered oxygen list. How did it get 2 zeros? So this is what gets returned. So let me make sure I understand what's happening here. The filter comes back on the second to last run. We're good to go. It runs through whatever's up here. It says cool. Let's go ahead back here. Running this filtered list. I'm gonna check on list at the item index, at the bit index, or at the item, which item we're currently on. Oh. No, that doesn't matter either. Because we have the same, that always has the same number. I want to make this an if statement because, just because. Because I don't know what's happening here. I don't know why it's not working. Zero. Then else. Let's do that. Let's just, I'm just testing something out. And look at that. Now I get, oh, it actually changes things up a lot, which is scarier to me. If items bit equals 0, the zeros are plus plus, else ones plus plus. Oh. Wait, was this always what I was doing? All right, we'll fix that up a little bit. And we're still getting 22. Okay, I just want to make sure that it wasn't the case statement. That I'm very concerned by this last, the last iteration. So in the very last iteration, all right, I need to put some zeros. All right, so watch this. If let's do something here. We're gonna say if bit equals 4. So only if it's on the 4th iteration, only if we made it to 4 here. Should we do anything? But if it's 4, I want you to print out I want you to print out string list item bit. Should it say checking this. All right, we'll do this first. Checking 0, 0. What the heck? Look at this. This is crazy. Let me actually. Checking. gonna do the string that I'm checking. And I'm gonna do the actual, the current one that I'm on. I'm gonna check the list as well. I wanna see the list. Or filtered list. Oh man. There we go. Oh my gosh, spent all of that time to get to this point. We found it. Oh my gosh. That was, whoo. I'm sure you all have been looking at me like, dude, are you stupid? Okay. I never even need to change that. Okay. We're looking for filtered list and not list. That's my fault. I should have been paying attention to where the irregularities were. I should have been looking for some consistency and looking for the outlier there. And now if we run it, there we go. We get the stupid 23. Spent a lot of time. I'm not even gonna remove the amount of time that I was searching for that. I want you to be able to see that you run into stuff like this all the time. I probably would have caught it faster if I wasn't attempting to record this and do this in front of you all, but we did catch it. So now, finally, we can go back down. We didn't even need to do, we kind of needed to do it. No, we didn't, but I'm not gonna change it at this point. And so I'm gonna print this out. I'll multiply them together for my day 2 output. And we get 230 like we should have gotten. 230, excellent. We get that. And so now if we change our input to be the proper input, and we run it, gross. We should have removed some of this. Let me get the actual numbers. I hate when Go does this. I don't hate when Go does this, but the number is large. It's, what's this, like 3,900,000. Well, yeah, let me, what is it? 3,969,1,2. And I think I need, 3, hold on, 1, 2, 3, 1, 2, 3. How many zeros? Never mind. I don't know how to do that. Let me change this and let's actually see. Oh, did I not convert them to binary? See, you know, my brain's messing with me because of all this time that I'm spending with this. It should return the binary converted filtered list 0. Binary convert will returning results. Let me go ahead and once again burn oxygen. And I'll do the math myself, which is annoying because it's annoying. Oh, okay. So 1,071 times 3706. I don't know why. I mean, Go is giving me the right output. I think it's just, what's that scientific notation? I don't remember. I haven't done math class in a long time. There we go. 3,969. Almost had it. 126. Okay, I will learn how to read that later, because I forgot I had all this output. But yeah, there we go. I think this is the right answer, and we did it. That was a lot, mostly because of my own mistakes, because of missing my own little problem, but I'm not going to remove it. I'm not going to remove all of that. I'm not going to clean it up because, again, I want you to see the process. I want you to see the process that I go through. If we weren't doing this for a recording purposes, I would plan this out a little bit more. I would read through, I'd sketch something out, and I think we're going to have to do that for, judging by this one, I think we're going to have to do that to get through, you know, the rest of them. But we did not use any crazy programming concepts. We didn't have to use any crazy map reduce functions or any crazy filtering functions. We did everything by hand here, and we're not using anything out of the ordinary. They're just for loops here. There are just using variables here. There are assignment operators. We are using multiple functions to pass things back and forth. We're using conditionals. We're using if else's. We had a switch statement in there. We are using programming fundamentals. We will have to get, like I said, we'll probably need to get it a little deeper and a little bit smarter to get through things a little bit faster as we kind of move on. But yeah, we got through it. I hope you understand it. I'm going to push this to GitHub now. The link to the GitHub will be in the description below. Feel free to pull it down to look at the code. I'd also love to see ways that you optimize this. I'm not going to spend any time going through and optimizing this right now. I am going to remove these statements here because we don't need them. But show me what I'd love to see what you did. I'd love to see how you took this code and made it better, made it more efficient, remove some things, skip some dumb stuff that we did. But again, we read through it and we kind of cowboy coded this and we got through it. Next time, day 4, we're definitely going to take a little bit of time to be a little bit more thoughtful about it because we're going to have to be. So if you have any questions, leave them in the comments below. I know this is going to be a little bit of a long one. Thanks for sticking through to this point with me. I'm glad we were able to solve it. We now have 6 sweet stars. Hop back in tomorrow and see if we can get the next 2 stars. Have a good day. If you enjoyed this content, please give this video a thumbs up. If you want to see more, please consider subscribing. You can also head over to our Twitch channel where we offer completely free boot camps in computer science and software engineering, DevOps and site reliability engineering concepts, as well as cloud computing. We also have a lead on a number of engineering roles. So if you're interested in any of those, shoot your resume over to resumes@mastermind.io, and we'd love to get you connected to companies who would love to have you.